Yeah, the chi-squared test of independence. This is when we have a two-way table. So if we have two categorical variables and want to know if they're independent or homogeneous, we use this test. The null hypothesis is that the two variables are independent or that there is no association. The alternative hypothesis is that the two values are not independent or there is an association. You can say it either way. As an example, if we let's say we take a sample of 167 people and ask them what their eye color is and their gender, and we have the following results. So the question would be, is eye color independent of what your gender is, or is there an association between eye color and gender? So our null hypothesis is that there is no association. Doesn't matter what gender you are, the distribution of eye color is the same. Or we can say that they're independent of each other. In order to do this test, we go to Stat, Test, and this is going to be the chi-squared test. So when you say this one, make sure that you write down that we did a chi-squared test of independence. You click Enter. Now, this asks for two different matrices, observed and expected, A and B. So we need to put something in this matrix A. So let's go back and we're going to do that first. So second function quit, and we're going to go to second matrix, edit, and we'll just leave the easiest if we leave that to A. Now we have 2 rows and we have 5 columns. So 2, 5. And if you don't know what to put in there, try one or the other, and the table here should look like the table here. Do not include the totals. The totals do not get put in this. So now if I put 20, 30, and you just keep hitting enter, it'll automatically go to the next spot in the same row until it exhausts them all. So 10, then 15, then 10. Now I'm going to go down to the next row, and it automatically did that. I didn't have to do anything special. So it's 25, 15, 12, 20, and 10. Okay, now we can do a little double check, make sure that 20, 25, 30, 15, 10, 12, 15, 20, 10, and 10. So all the data is in my matrix A. So now that it's in matrix A, I just need to go to Stat, Test, and I'm going to go back to that chi-squared test. Okay, the one that doesn't have the GOF. So this is a chi-squared test of independence. I click Enter. Matrix A is what I just put in. I don't have to put anything in matrix B because it's going to automatically calculate that for me. So I click Calculate. And we got a chi-squared of 6.4, basically 6.4 after you round everything, with a p-value of 0.17. There is not enough evidence to say that eye color and gender are related or are associated, or that we failed to reject the null hypothesis. There's not enough evidence to say there's an association between the two. Degrees of freedom is 4. Remember, one way I looked at this, or the way I showed you in class, is if you take your data table and if you block off, and I'm going to go ahead and highlight this so you can see it. Okay, if I block off one row of the table, or the last row, and I block off the last column, the number of cells left over is your degrees of freedom. 1, 2, 3, 4. Notice we have 4 degrees of freedom. Another way to look at this is the number of columns minus 1 times the number of rows minus 1. And again, in this case, that would be 5 minus 1, which is 4, times 2 minus 1, which is 1. So 4 times 1 is 4. So there's our degrees of freedom.